welcome to the deep dive. Okay, think about those big sci-fi movies.
Yeah.
You know, laser beams zapping everywhere, plasma force fields, robot armies marching perfectly in sync.
Sure, classic stuff.
For the longest time, that was just pure fantasy, right?
Yeah.
Movie magic.
Absolutely.
But, well, what if I told you that stuff isn't just movie magic anymore? That some of these are real technologies actually being deployed right now.
Okay. I see where you're going.
Today, in this deep dive, we're going to reveal 9 military weapons that tell us the future is now. We're really taking a journey through some truly groundbreaking advancements, things that honestly used to be purely what if.
Yeah.
And our mission, like always, is to pull out the really important bits, the key knowledge from our sources, basically giving you a shortcut to being genuinely well-informed about these cutting-edge innovations.
And we're going to explore them by what they do, their function, rather than just counting down a list, right, to really get the impact. And, the insights we've gathered come from looking deep into military R&D. It shows just how fast that line between science fiction and what reality is blurring.
It really is.
It's fascinating to see these concepts, things from novels and movies, now shaping actual defense strategies. The pace is just incredible.
Right, let's just jump straight in. First big area, robotics and autonomous systems, the rise of the machines, basically.
Okay.
And first up, under that umbrella, is this incredible concept, swarm bots.
Ah, yes.
So when we talk about robots acting together like a beehive, but for military stuff, what does that actually look like?
Well, basically, you've got individual robots, but they coordinate. They act as one unified group. And they can do this in the air or even underwater.
Okay.
But the really disruptive thing here isn't just, using them for maybe healthcare or disaster rescue, though that's possible. It's how the U.S. military is researching them specifically for conflict situations.
Why the military interest specifically?
It boils down to a couple of things. They're relatively low cost, which is a big factor.
Right.
And that lets them act as a force multiplier. So a smaller number of soldiers can effectively have the impact of a much larger force because these units are, well, kind of cheap and disposable.
Disposal robots.
Yeah. And this resilience, this network idea, it fundamentally changes things. If one bot gets knocked out, the network just compensates. The mission continues. It makes them incredibly hard to truly destroy as a group.
That resilience sounds like the key. And there was that demonstration, wasn't there, back in 2014?
The Office of Naval Research.
They had, 13 boats?
Yeah.
Operating with no human control at all?
Exactly. Performing these complex maneuvers, all perfectly synchronized, it really is like watching a hive mind emerge, but, on the water.
Okay, moving from swarms to something maybe a bit more direct. Something that sounds like it's straight out of a video game. The Modular Advanced Armed Robotics System.
Mars.
Now, this one gets really interesting because apparently the Marines are testing this thing. It's like a mini robotic tank. And get this, it can actually drag a wounded soldier off the battlefield while it's firing.
Yeah, that's a significant capability. It's a big step towards, grunting human soldiers and maybe even replacing them in really high-risk situations. It definitely changes ground combat dynamics.
It's developed by a company called Magnetic.
That's right. It's an unmanned ground vehicle, a UGV, designed specifically to boost security for ground troops and, step in when missions get too dangerous for people.
And it's pretty versatile. I read it has a top speed of, about 7 miles per hour?
Yeah, specifically so troops can keep pace with it, walk alongside.
Okay. And you control it remotely from maybe a kilometer away using some kind of tactical controller.
That's the idea. Remote operation for safety.
And the firepower options are, varied. Machine guns, grenade launchers, different ammo like tear gas, buckshot, smoke, high explosives. It can go from non-lethal, like sirens or disorienting lasers, all the way up to, very lethal.
Right, it covers that whole spectrum.
The Marine Corps Warfighting Lab was even hoping for an unarmed version just for infantry squads, maybe back in 2018.
Yeah, for logistics and support roles, too.
And Mars apparently has a bigger sibling, the RVM cart. That thing can carry an M134 minigun firing like 2,000 to 3,000 rounds a minute.
Indeed. These systems are clearly about enhancing firepower and protecting personnel. It's pushing warfare further towards remote and semi-autonomous operations.
Okay, let's switch gears. Next up, directed energy and defensive systems. This is where energy itself becomes, both a shield and a sword.
A fascinating area.
First, plasma force fields. Seriously. Imagine a real-life force field, just like in the movies, protecting vehicles from explosions.
It does sound like Star Trek, doesn't it? But yeah, Boeing is actually developing this.
So how does it work? Is it like a constant bubble?
Not exactly. What's striking is the precision and efficiency. It's a real shift in protection strategy. Boeing got a patent for this. The idea is to defend high-priority targets, like vehicles, by absorbing the shock waves from explosions, missiles, IEDs, that sort of thing.
Absorbing shock waves. How?
Okay, it works by heating the air around the vehicle, like incredibly quickly to very high temperatures. This creates superheated plasma.
Plasma.
Yeah. And then, using a magnetic field, they control the flow of that plasma to form this dense, viscous shield. It makes it really hard for the energy or even shrapnel from the blast wave to get through. It slows it down or deflects it.
Wow. And the really clever part, I thought, was that it doesn't have to be on all the time.
Exactly. That's the efficiency part. It's only created in small, specific areas just when a threat is detected, so it doesn't drain power constantly and can last much longer.
Okay, so from shielding with plasma, let's talk about using energy to, well, attack, or at least disable.
Well, that's the offensive side of directed energy.
Let's talk about the Laser Avenger, also known as HEL-MD High Energy Laser Mobile Demonstrator.
Uh-huh.
The big headline here, for me anyway, was you could potentially operate a laser cannon with an Xbox controller.
Yeah, that detail certainly catches the eye. It's a collaboration between the U.S. Army and Boeing. It's a directed energy weapon, basically a 10-kilowatt laser cannon mounted on a vehicle.
And it can take out things like missiles, mortar shells.
That's the capability, yes, right from the vehicle.
And Boeing's working on a stronger one, too, like 60 kilowatts.
That's right. A more powerful version aimed at tackling larger threats like high-range missiles and, significantly, UAVs, drones.
Which are everywhere now.
Exactly. And yeah, the interface. Using an Xbox controller. One person drives the truck, another sits there with a laptop and the controller, locking onto targets and firing the laser.
It really blurs that line between gaming and, well, actual warfare, doesn't it?
It certainly raises questions about training, operator demographics, the whole approach.
Okay, sticking with lasers, let's move to another system. This one seems focused specifically on that drone problem.
Ah, yes. The laser weapon system, or
Oh.
LAW-WS. And a crucial takeaway here is just how cost-effective this approach is against that growing drone threat. It's potentially a game changer.
So this was developed by the Navy because of all the drones popping up, military and civilian?
Precisely. The proliferation of drones really spurred its development. It started as a roughly $40 million prototype system designed primarily for defense.
And how does it work? Does it just melt them?
It essentially punches holes through UAVs using a 30-kilowatt photon beam. It emits an infrared beam from a solid-state laser array. The goal is to destroy critical components or disable the drone systems.
And it's powerful, adjustable power up to 30,000 watts.
Yeah, the power can be tuned. And it's fast. It can disable a drone in just a few seconds.
And it can operate automatically without a human pulling the trigger.
It has that capability, yes. Automatic engagement. The Navy put the first prototype on the USS Ponce back in 2014.
Did it work?
Reports say it successfully took down unmanned aerial drones and even simulated small boat attackers in tests.
Okay, but the real kicker, you mentioned cost effectiveness.
Absolutely. Compared to firing expensive missiles at cheap drones, LAW-WS is incredibly efficient. A single laser shot costs, wait for it, about $1.
$1, seriously.
Just about $1. So you can see why it's considered invaluable for protecting military assets, airports, other high-profile targets. The economics make sense against swarms of cheap threats.
Okay, from lasers frying drones to something, well, different. Still directed energy, but designed to be non-lethal. The active denial system, ADS, often called a heat ray.
Right.
Let's unpack this. A heat ray that makes you feel like your skin is burning, but doesn't cause permanent damage. That sounds unpleasant.
It is designed to be unpleasant, that's the point. It's a counter-personnel system the U.S. military developed for crowd control security situations.
So, not for killing, but for making people back off.
Exactly. It induces a sensation of intense heat on the skin, prompting an immediate withdrawal reflex. It's different from kinetic methods like rubber bullets or water cannons, which can cause physical trauma.
How does it do that? Make you feel hot without burning you?
It fires a high-powered beam of 95 gigahertz waves, millimeter waves, similar in frequency to microwaves, but much more focused and controlled.
Okay.
These waves excite the water molecules just in the very top layers of your skin, epidermis mostly. This causes an instant heating sensation, But because the penetration is so shallow, it causes intense discomfort without generally causing lasting burns.
Generally.
Well, in rare cases, prolonged exposure could cause blisters, but the operational intent is for people to move out of the beam almost instantly because the sensation is so intolerable. The military tested it extensively, over 13,000 volunteers apparently, and they affirm its safety and limited side effects when used correctly.
Has it actually been used?
It was deployed by NATO forces in Afghanistan back in 2010, but reports say it was never actually used against enemy combatants or crowds there. And while the military versions are pretty big truck-mounted systems, there are ongoing efforts to make them smaller, more portable, use less power. And smaller versions, developed by a company called Pantheon, are apparently available to police and prison authorities in the U.S. The L.A. County Jail reportedly has one installed on the ceiling.
Wow. Okay, that definitely raises some questions about use cases, ethics.
It certainly does.
Yeah.
Using a weapon designed to inflict intense discomfort, even if non-lethal, for crowd control is ethically complex, no doubt.
All right, let's shift to our final category, precision and power, reshading how engagements actually happen on the ground.
Okay.
First up, the Advanced Precision Kill Weapon System, or APKWS.
APKWS, right.
So what does this mean in practice? The takeaway seems to be the ability to turn ordinary, dumb rockets into super precise instruments, maybe preventing unnecessary harm.
That's the core idea. It's a high-precision rocket guidance system developed by BAE Systems working closely with the U.S. government.
How does it guide the rocket?
It uses a semi-active laser guidance mechanism. So a soldier on the ground, or maybe a drone operator, paints the target with a laser designator.
Okay.
The APKWS kit on the rocket then sees that laser spot and homes in on it. It makes it a very accurate point-and-shoot system, and it doesn't need any external maintenance once it's fitted.
And the really smart part is that it's like a kit, a plug-and-play device.
Exactly. That's key. You can fit this guidance kit onto existing standard unguided rockets, instantly upgrading them to precision munitions. It's highly adaptable.
And it's been used in places like Iraq and Afghanistan.
Yes, the U.S. Marine Corps has deployed it. And it's often highlighted, as you said, for its claimed ability to minimize collateral damage, prevent civilian deaths, while still destroying the intended target precisely.
Precision is definitely a theme here. Which brings us to precision-guided firearms, PGFs.
Right, and this raises a key question about what happens when that kind of precision becomes much more accessible.
So this comes from an American tech company, Tracking Point. They made the first PGFs.
That's them.
And these are basically smart guns, functioning like a video game.
That's a common analogy, yeah. The trigger is essentially wired into the scope's computer. It has sensors for range, wind, drop, all that.
And it won't fire until it's locked on.
Pretty much. The shooter tags the target in the scope with a red dot. Then they hold the trigger. The gun's internal system calculates the perfect firing solution, and it only fires when the crosshairs are precisely aligned with that tag, compensating for distance, movement, even shooter wobble.
And they could hit targets like over 1,000 yards away.
That's the capability, yes. Remarkable long-range accuracy.
Plus they have Wi-Fi
Mm-hmm.
and a display,
Right.
so people can post their shots online.
Uh-huh. That feature definitely added to the controversy.
Yeah, I can imagine. The idea that, quote, just about anybody could become a sniper, that's unsettling.
It definitely sparked debate. And the cost. Initially, they were very expensive, right? Like $22,000 to $27,000.
Yeah, but now there are cheaper models, around $5,000.
That's right, bringing the technology within reach of more people. And the CEO of Tracking Point, Jason Shaw, who's a former Marine captain, he's apparently expressed hope for a U.S. military contract, arguing the benefits of extreme accuracy and the Wi-Fi allowing soldiers to share target data instantly.
Okay, one last weapon.
Yeah.
And this one feels like a huge leap. No gunpowder, no explosives.
Might come.
Real guns.
Oh, the electromagnetic option.
Yeah. Here's where it gets really wild. A gun that fires projectiles at a mile a second without any gunpowder at all.
That's the concept. BAE Systems has been developing this for the U.S. Navy for, what, over a decade now?
Yeah, and it cost a fortune, like over $500 million.
Significant investment. And the core idea is a fundamental shift away from chemical propellants.
So how does it work if there's no explosion?
Okay, what's fascinating here is the sheer scale of the energy involved. Overcoming that power challenge could totally revolutionize naval warfare. Basically, they use immense electromagnetic forces. They build up a huge electrical charge, around 32 megajoules of energy. Then they channel that energy down two parallel conductive rails. The projectile sits between these rails, completing a circuit.
Right.
The massive current creates an incredibly powerful electromagnetic field, Lorentz force, which accelerates the projectile down the rails at astonishing speed. We're talking 4,500 miles per hour.
Miles per hour. Wow. More than a mile a second.
Exactly. And the projectile itself is typically non-explosive, usually a solid slug, maybe tungsten pellets in an aluminum casing, around 25 pounds.
So the damage comes purely from the speed, the kinetic energy.
Precisely. And a big advantage is safety. Eliminating explosive propellants and warheads makes handling and storing the ammunition a much safer onboard ships.
But they have problems, right? These things aren't quite ready for prime time.
They face huge challenges. The main ones are the immense forces and heat generated. They tend to tear themselves apart. The rails erode very quickly under the extreme temperatures and pressures.
Okay.
And the power requirement is just massive, about 25 megawatts per shot. That's enough electricity to power, like nearly 19,000 homes just for one firing sequence.
Whoa. So generating and storing that kind of power on a ship is tough.
Extremely tough. But advances are happening fast. Better power generation, new alloys that can withstand the forces. Insiders seem to think it won't be that long, maybe within 10 years, before we see these installed on battleships.
And the military sees them as maybe a cheaper way to deal with missiles.
Yeah, potentially as a missile defense system. Firing relatively cheap slugs at hypervelocity could take out almost any incoming threat planes, missiles, maybe even tanks on shore.
Okay, wow. So we've covered a lot today. Robotic swarms, force fields, lasers, smart bullets, railguns.
It's a remarkable range of technologies, isn't it? That whole idea that the sci-fi of yesterday is becoming the fact of today, it's never felt more real.
Yeah.
The pace of innovation is just, it's accelerating. It really is.
So what does all this mean for you listening right now? Well, it means the future isn't just somewhere off on the horizon. It's pretty much here. It's fascinating, maybe a little scary, but understanding these shifts is really key to being truly well-informed about the world we're living in.
And maybe it leaves us with a bigger question. As these technologies get more powerful, more autonomous, how do we as a society guide their development? How do we balance the potential defensive benefits with the really complex ethical questions they bring up?
That's definitely something to think about. We hope this deep dive has given you a clear picture of just how fast things are changing and plenty to mull over.